Hi everyone, Zach here, and welcome to lesson 63 in this series on developing a survival game. In this video, we'll continue working on our day-night cycle with a particular focus on our star cube map and our sky sphere itself. So we'll be looking at the material. Now, the prep video for this lesson was taken directly from the original recording of this lesson. Therefore, there'll be a bit of a jump in this video. I'll try to put notations in where the jumps are, but that jump doesn't affect what we're doing. I'm just removing where I explained some of the material and thought, hey, this would be better as a prep video. This video and this series have been brought to you by Patreon sponsors, and you too can help this channel out, and all you have to do is hit that like button down below. And if you've not already, also hit that subscribe icon and make sure to turn on all notifications. Okay, open up your project and we'll make a start. Hi everyone, and welcome back to the editor. And in today's video, we're going to finish out our day-night cycle by creating the day-night cycle. In the last video, all we did was start the timer that we're going to use for our game time. So if you're coming from outside this series, I will actually point out what part you need to bypass and what you need to do if you just want to use the sky atmosphere for a day-night cycle. In addition, before we continue, I need to give credit to where I got our cube map from, and I will have a link in the description to the actual website along with the random seed that I used. And the cube map comes from this lovely GitHub by Tyro. I think I said that name right. That is, in fact, the seed I did use for this series. The only difference is we do not have a sun and we don't have the nebula, because the nebula made the corners of the cube map really stand out. I will also say, though, that the cube map is in much better shape and look on here because I had to make the cube map. I had to stitch it together from the download here to actually get it to work in Unreal. It isn't the best, but again, as a reminder, this is a free tutorial. The materials, textures, the use of the trees, things like that are all meant to be placeholders to help you understand how pieces work. So that said, please remember to, that this isn't going to look 100% perfect, but it's going to show you what you can do with a good texture. Because again, I am not an artist. I'm a coder. I work with code. I work with logic. Art is terrifying to me. Okay, so that said, what we're going to do is we are going to open our assets folder for this series. And in our assets folder, we have world textures. And by the way, if you haven't worked out, I'm clearly updating the folder and not changing and re-uploading it to the same URL. So if you've downloaded it earlier and you don't have Sky, like you downloaded it because when I was doing the materials and Sky wasn't there, well, it's there now. Most of you will actually only see this after I put Sky in because, I'm releasing it earlier to Patreon sponsors. In Sky, you will find the HDR cube map. Now, the way I did this was I downloaded the cube map from the website I just showed you. I took the panels and I stitched them together, oddly in Unreal. A better way would have been to do it in Photoshop using the guidance from Unreal itself on how to do that. Again, there's a link in the description below about how to actually create a cube map a proper way. I'll also include my terrifying instructions for how I did it. And I do mean terrifying. Anyone who's ever made a cube map is going to stare at it and go, that seems really brilliant, but it's going to turn out bad. So all of that said, let's go to textures. In textures, what we're going to do is create a new folder for our sky texture. So I'm just going to right click, do sky, and I'm going to open that up, of course, and I am going to drag and drop the HDR texture in. It will import it as a cube map because it's an HDR. So if we pop this open, you've already noticed when I highlighted it, it says texture cube. And we go in here and we can see our cube map. Don't worry about how stretched it's looking. That's normal for a cube map like this. It is going to be a bit pixelated either way, but it is what it is. What we want to do is extend out the advanced options under compression settings, and we're going to change our compression maximum. Notice that here it's a 4K texture or a 4x2K texture. Notice power of 2 numbers being used here, but it's being displayed as a 1K, and I'm not even sure what 512 really is at the end of the day. Cube map, and then we have our in-game settings, which really mess with it. Now, if you wanted to be closer to what it should be, what you could do is change this to 496. And that is a bit intensive, but you'll notice when I do this and it finishes loading, that the quality does drastically increase. All right, so it's done updating. If we zoom out now, well, it kind of looks the same, but we now can see a little bit more clearly what's going on here. And we notice though that the max in-game is still at 2K. If you really feel like pushing it and making this a 4K cube map, you can, but I will tell you that the max in game will stay at 2048. It doesn't go higher. In fact, if you change this to 2048, that stays at 2048. If you don't believe me, here is a cube map from the prep file. I changed it there as well, just to check what I was saying. All right, we do need to make some other changes. We do want SRB on, which for some reason didn't click. Oh, sorry. Actually, no, don't turn SRB on. Leave this on HDR. That's better compression for what we're doing. I lied to you. Change brightness to 2. Again, that's going to take a moment for it to compile. And then we're going to take care of the MIP mapping issues. Because, yes, there are MIP mapping issues. All right, with it at 2, what we're going to do is address the MIP mapping issues. Now, you might be going, well, it has MIPs. Why is that? There are no MIP mapping issues. What do you want about? That's the issue. It has MIPs. Think about this for a minute. MIP mapping is used when we want to stream a texture based on LOD. How far away is the sky from us at all times? It's always going to be at, yeah. So either we don't want it to stream, that's one thing, and we don't want to have to compress extra power of 2 versions of this material. Because remember, this is already power 2, so it's automatically going to make our MIP maps. So what we're going to do from level of detail is expand this out. We're going to go to from texture group, and you have 2 options. You can either set it so there are no MIP maps, or level existing MIPs. I'm going to use level existing MIPs, which will drop my MIP map count to 1 there. I am then going to find the never stream button and just click that. Because we don't want to stream this. It is what it is. It's not going to look so stretched out, don't worry. Now, I will say that the corners of this actually are noticeable because my stitching job was probably not the best. I probably made some mistakes, let's be fair. Anyway, let's close that out. And we now have the texture that we're going to work with. Hey everyone, Zach here from the future. Here's where I explained that the material for the prep was included in this video. I clearly removed it. Regardless, in the midst of what I explained, I mentioned that we will work on the material first, so that is what we will do. To follow along while we create the actual material. So we're going to materials. We're going to create a new folder called, you guessed it, Sky. And in here, we're going to create a new material called m_sky. Let's pop this open. You're punishing me for what I did earlier when I was doing the instance editing. And we're going to create our sky material. So all we're going to do here is we're going to take this as a surface that is opaque, that is unlit, and, well, that is the basic setup for a skybox. We are going to also add in use static lighting, and we don't need to tessellate it because if your sky is tessellating, I have questions. Some very, very, very concerning questions I need to ask. All right, so now I'm going to do the explanation. Feel free to skip. So before you go on to the next part of the tutorial, what we're going to do is we are going to create a cube map, or we've created a map. We're going to apply the cube map to our world. We only want the stars to show when it is night. So there are a couple of ways we can handle this. We could check what the overall luminance is, and there's 2 ways to do that. We could do our sky atmosphere luminance, we could do our sky atmosphere lit luminance, or we could do our sun direction. Now, you might run across some epic videos where they've done similar things. I want you to try to work out the system. So pause the video here and try to work out how that's going to work. Okay, now, if you haven't paused the video, fair enough. If you try to work out at least the logic, you might be thinking, oh, well, we need to use the direction. The direction, it doesn't help really because... So the direction doesn't work because it ranges 0 to 1. So if we're lerping, say, between our day and night, we would have to really find some strong controls to keep our clouds from, or our stars from showing up early. Or if we only were checking if this is 0 or 1, then they'll just turn on and off. Okay, so if we can't do that, maybe we could use, say, our view luminance and our sky atmosphere light luminance, or one of the 2. Well, that's great, because when the sun starts going down, the luminance gets lighter, so the intensity gets lighter. the gradient changes, we could lerp using that between our daytime and nighttime look. Okay, what happens when the sky is overcast and there are clouds all over? The sun's still out. The sun should be blotting out the stars, but now the stars are appearing. Right. Well, what we could do then is combine our directional light and our luminance. In fact, actually, I'll be completely honest with you. That's exactly what I did in the original version of this. Of course, this ran into its own issues. You can see here's all the prep for this, by the way. That ran into its own issues where the stars were showing up under the horizons during a storm. So instead of that, we're going to use a very different approach. Now, I need to give credit where credit's due. This system was worked out by one of my community members named Lord Deep Fryer. I can't say that in the actual proper way of saying it. It's Lord Frittus, which translates as Deep Fryer, so, you know, he agreed for Lord Deep Fryer instead of me trying to say French words on stream. So what we're going to, and also, to be clear, the system that he's worked out is derived from my system, but it is significantly more efficient than my system. It's easier to walk through, it's less instructions, it's something like, I think, 108 instructions shorter than my material setup. So really, even though he claims it's derived from my system, full credit to him for his work on helping me debug this. So yeah, props to Lord Frittus or Lord Deep Fryer. So let's get started with our actual system. And what we're going to do is we're going to start with the stars, our star field itself. So we're going to do a texture sample. And our texture sample will be the cube map that we imported earlier. So we're going to find our T star cube map, and this will be linear color. We will do this from the texture asset itself, and we'll make no changes here. Now what we need to do is we need to take in the direction of the cube map. We need to rotate for our UVs based on that direction. The way we're going to do that is we are going to pull back from the UV here and do reflection vector, if I can spell vector right. And you want reflection vector WS. And you're going to get this customized world normal. And notice as I move, you can see the stars being stretched there. That's normal, don't worry. Well, what we're going to do is we're going to get the light direction for this. So, you know, one of those nodes I talked about earlier, hey, our light direction, where this is our direction of our light. So sky, atmosphere, light direction. We're going to plug that into there, if I can get this to work properly, and notice now what's happening. So what these two nodes are doing is it takes direction to change direction. So it takes the direction of the light, of the sun, takes sun direction to change direction of cube. So rotation of cube map. That's what we're doing here. We're just rotating the cube map around. All right. So that's fairly simple stuff so far, right? Anyone else scratching their head? The next thing we need to do is then we need to make this stronger. And what I'm going to say is we're going to do a multiply. And I am going to actually create a parameter for this one. So I'm going to right click the B here, and this will be my star intensity. And I'm just going to set this as a default of 3. In my original version it was 10, but that led to some fun issues. All right, so all we're doing here is we're setting the star field. This is literally what's happening. Set star field. Next, what we need to do is we need to control for the brightness of the stars based on our sun position. So we're going to control our intensity here based on our sun position. So we need to use a dot product. We haven't seen one of these since the water section, I realize. And we're going to control for it in the X and Y axis. The way we do that is we hold down 3 and we eliminate our blue by going to -1. At least that's how I understand this. I am sure Deep Fryer is cringing as I say this because I probably just got that wrong, but that's just the way I understand it. Again, we're going to multiply this, and I'm just going to do a simple scalar. I'm not going to create a parameter for this. At least not yet. I'm actually going to control, actually I will. This will be our control intensity. And we'll explore how these work in just a moment. Control intensity. I'm going to default the value again out to 3 for this one. And that's going to go into my B there. And then I'm going to do a constraint bias scale, which is a function or expression that takes an input value and adds a bias value to it. So again, anyone familiar with stats, this is tau, or random effects. And then it multiplies it by scaling factor outputted. It's outputted as the result. So if we just pull off of here and do constraint, if I can spell, constraint, wow, I can't spell. Oh, it's constant bias, not constraint. That's why I can't find it. I can read my own notes. And we're gonna leave it as the scale of 0.5 with a bias of 1. So there's no change there. We are going to then clamp this result, or if you really feel like it, you could use a saturate node instead. So we're gonna clamp this between 0 and 1. And then we are going to increase this to a particular power, and that power will be a power of 3. So we'll do power, and we will, again, create a variable for our exponent, and this will be our intensity X. And again, like I said, we're defaulting this to 3. Apparently we're on a 3 streak today. And then what we're going to do is we're going to multiply this. So what we're going to multiply this by is the pixel offset. And so what we're going to do is just come down here and do pixel normal WS, so world space. And we need to only, again, care about our left and right, our X and Y. So we're going to do a mask this time around. It's a component mask. We're going to unmark the R and G and mark our Z, which is B. And we are going to then multiply this by a negative number. And this will be, and I'm not going to create a parameter for this one, I'm just going to create a scalar. This value will be negative 20. You thought it was going to be negative 3, I bet. And then we are going to clamp this so that we are staying within the range of 0 to 1. All right, let's move this and plug that into our multiply. With our multiply, what we're going to do is we're going to add this into our star field. So again, that's how we're controlling for the intensity of the light and how bright our stars are. All right, so this is sort of the default intensity. This is intensity in relation to how light our sky is. So the top 2 layers of this really are what's setting or controlling our, I hate when that happens, controls brightness of stars based on position of sun. Now, really to get this to work, what we need to do is we need to pick between which one do we want to use. So this is nighttime. This is our night. Let's just count this all out as night. All of this is night in our star field being set up, how intense it is. What we need to do is we need to pick between what value is greater. Is this value greater, or is our current value of our sky greater, which was our daytime sky? So we have a max node. So we're going to do max, and this will be B, just because it doesn't really matter. It's picking between A and B, but I'm putting in B because I'm going to do A at the top here. And what A is we're going to use the sun's glow and tint. So we're going to use the sky atmosphere aerial perspective. We are going to mask this on all channels but the alpha. There we go. And we are then, if this value, if our glow on our sky is greater than whatever we're putting out here, and this will work per area, so we get that nice day to nighttime transition, which, by the way, does also work in the use and combination of the sky direction and sky luminance one that I put up on screen earlier. So again, we have stars appearing as the sun is setting, but they're not going to appear near where the sun is. We will have to adjust that a tiny bit. We then take this value and add it into our sky light disk luminance. So again, we're adding it into our sun. We're taking whatever value is here and we're adding that to our sun. So if it's 0 on our sun, thus it's dark, then all we're doing is adding in the intensity from our star field, which is relatively minor, but does give us some nice ambient light. If it's this value, then we're adding it to the intensity around our daytime. Now, of course, we could make this a little bit more complex, but this, we just need a base system, honestly, and this does exactly what we need it to do. So, hey, we have our, why is that actually giving me a preview in this version? Cool, I didn't get a preview in my other version. I'm a bit perplexed by this. I'm just gonna double check my settings real quick to make sure I haven't screwed something up. All right, so I did skip something. In your search details with msky selected, type in the word sky, and then mark is sky, and the preview should go away. We do need that marked as sky. That is a requirement for this to work. All right, so how do we apply this material? Well, we're gonna cheat just a tiny bit. I could create a giant sphere in Blender, invert the normals, and export it. Or I could just go to Engine Content, type in the word sky, and look for the static mesh, which is that right there. I'm gonna take said static mesh. I am going to go to my survival game, go to my meshes, and I'm going to copy it into there. I'm gonna move it one more time, by the way, once I've done that. I'm going to go into my meshes. I'm going to delete my search for sky. I'm going to create a new folder called, well, sky, oddly enough, and move the static mesh into there. Boom, done. Go back to my materials. Control S, save everything. Go to my sky. We're going to create a material instance, and this will be our sky instance. I'm going to then go to my meshes again. Go to my sky mesh here. And I'm just going to, well, open it up and change my default material on this to my M sky instance that we just created in our survival game material sky. Hey, look, there's my lovely cube map. You can actually see the corners. Which bugs me, but whatever. All right, and you know, we can change light map resolution as we need. We can change other things as we need. But here's what's really interesting. Why do we just do a Skysphere if we deleted our earlier one? Well, our Skysphere instantly works with our atmosphere. So if we drag this into the world, notice we have this error message. I'm gonna just move back a bit. That the scene contains a sky dome mesh with a sky material, which is why I had to make it a sky material, but it does not cover this part of the screen. I'm not sure why it's not showing up there. It should be, because we're actually not in the mesh. If I come around this way, it's still over there. So our atmosphere isn't being covered, and that's because if we move closer, you can see the skies in there. Boom. What we need to do is take this sky sphere here, and we need to, well, make it massive. So I'm gonna just hit the lock button so I can change all three values at once, and I'm gonna set it to the size of our planet, which was 1,000 Unreal units. And when I look up, well, I'm getting stars, which one I shouldn't be at this stage, but we'll take care of that in just a moment. I'm going to try to move the static mesh, if it will let me, into my sky folder. There we go. And I'm going to just save this real quick. And I'm going to rebuild the lighting. Once it's done rebuilding, we'll take a look at making sure that everything is set up correctly. So go ahead and rebuild your lighting. I'm going to pause the recording here. All right, so built the lighting, and whilst doing that, I was just peeking over at the material, and the issue is I put the wrong node there. It's not add. We do need to combine these two. That's true. I didn't mislead you there. What we need to do is multiply them. That's going to be the difference here between this working and this not working, is that we're multiplying our Starfield with our check on the light intensity. So if we just save that now, boom, our stars are gone. Now let's have some fun with this. Let's move this to a noontime setting. Nothing up there. Let's go under the planet. This is the bug I had, by the way, where I need help. Nothing there. Let's go up. And what we're going to do is we're going to move our sun with Control L towards a sunset. And you can notice that a couple of stars have started to appear up there. Let's move this further down. And you notice now that there are more stars showing up. And let's go all the way down. And there is our box. Our nighttime skybox thingy. Our cube map. That's the word I'm looking for. Cube map. Okay. Having a moment there where I couldn't get the sun to return. All right, I'm just going to place it there. I'm going to delete the point light I accidentally just created. And we're going to go back to the light source. And we are going to do 0, -45, 0. So that it's showing up again on the eastern side, or what I'm calling the eastern side of the island. And we now have our nighttime map set up. Sorry for the tiny bit of a jump around the map. I was pondering if I was going to do this in 1 or 2 recordings, and just looking at the time, even if I edit this recording to take something out that I'm going to probably put in the prep video, still going to be a bit long. So I am going to do this as a 3-part section on the day-night cycle, and the next part definitely will be actually having the cycle in here. So we'll actually get the day-night part of it. We have the time, we have the cubes. Whee! So in the next bit, we will actually have our game clock from the last section and our Skysphere from this section or video, not section, work together to create our day-night cycle. That said, if you want to be here when we actually have that set up, make sure to hit the subscribe and notify icon. And we'll also be able to see the lightning properly at some point too. This series has been brought to you by Patreon sponsors like Hanas, Rian, Connor, and 1Volt10. And if you've enjoyed this video and you're looking forward to actually having a full, proper, smooth transition, whoa. I don't know what I clicked that caused that to happen. I'm gonna investigate that between the two videos, but if you've enjoyed this video as I get terrified by a floating tree, make sure to hit the like button down below. And if you want to find out why that tree was floating again, hit the subscribe and notify icon. Otherwise, I look forward to seeing you in the next tutorial, and I hope that you have a wonderful day. Seriously? What's with that tree?